Hey guys, welcome back. We were dealing with diamond and graphite in our previous classes, and we have discussed this thing in detail that how diamond and graphite have similar properties related to their basic chemical structure. Both of them have same formula carbon. So if the examiner is asking you that graphite is reacting or graphite is burning in the presence of oxygen or air, you are going to write C plus O2 to show this reaction, because O2, that's the oxygen, is the only part from air which is participating in the burning process. Remember this thing that oxygen is not a flammable gas, rather oxygen is a burning helping gas. CH4, for example, is one of the gas which is a burning gas. It is a gas which is coming in our home and coming in our home as well. It is available in our burners and we are using it for cooking and heating. Similarly, hydrogen is also a flammable gas, but this oxygen is a burning helping gas. It is not a flammable gas. Okay, so here on the board you can see these are the properties of graphite, which I have written in the previous lecture to tell you that graphite is used as an electrode in electrolysis, and what are the reasons why it is used. Examiner is asking this question for like 3 marks in some of the papers. So right now I am telling you the next topic, and that is the giant covalently bonded structure number 3, and this is silicon oxide, formula SiO2. You can call it silicon dioxide or silicon oxide, and it is also called as silica as well, but it is much better to call it silicon oxide. Okay, silicon dioxide is also called silicon oxide. I am telling you, this is also silica, but better is this to call it silicon dioxide or silicon oxide. It's a major component of glass preparation. So this is sand basically. Okay, so if examiner is asking you that sand, draw the structure of sand, you should know this thing that he is talking about silicon dioxide. In silicon dioxide, each of the silicon is making bond with four of the oxygen atom, whereas each of the oxygen atom is making bond with uh, two of the silicons. Okay, you can see this right now. It this and it is this and this is and this and this is like going on, and it's happening further and further. Okay, now, for example, let me go on to a new page. Okay. For example, this is silicon, and we know this thing that its atomic number is 14, so it is 284. It is just below carbon in group number 4, so it has 4 electrons in its outermost shell, and oxygen has an atomic number of 8, it is 26. Look, all of the 4 electrons from the outermost shell of silicon are involved in the bonding with 4 oxygen atoms separately. All of the single covalent bonds are formed, and we know this thing that oxygen is deficient of 2 electrons from its outermost shell, so it is going to share its 2 electrons with two of the silicon electrons. Hence, in this way, all the electrons from the outermost shell are involved in the bonding. No electrons are available to conduct electricity. No lone electrons are there. No unoccupied electron is there. So we can say that as all the electrons are involved in bonding, that's why silicon dioxide cannot conduct electricity. Okay, so I'm writing here no mobile electrons are available, so silicon oxide cannot conduct electricity. Okay, so Now there is another point that silicon oxide has a very high melting point and boiling point. What is the melting point of boiling point of diamond, graphite, and silicon oxide? Examiner is not going to ask the exact value from you. He's just saying this thing that as they are giant covalently bonded structures, so they have high melting points and boiling points definitely. But they are asking this thing, what's the reason behind that? Okay, so here we are discussing the same point which we have discussed earlier in diamond, that in case of silicon oxide, as there is a continuous covalent bonding, that's why a high heat energy is required to break continuous covalent bonding. That's why silicon oxide has a high melting point value. So we have discussed about its melting point value and we have discussed about its conduction property. And now we are moving on to the next bonding, and that is the third category of the bonding. Here I am changing the board. This is the last point of this chapter. The big chapter of bonding is now going to an end, and that is a metallic bonding. No doubt we have discussed this metallic bonding in metal, the structure, general structure of a metal and alloy. But here right now, I am telling you that this is the third category of the bonding, which is part of your syllabus. So we have discussed already about ionic bonding, about covalent bonding, and now we are discussing about metallic bonding. Okay, it is existing. First point is this, that it is existing in case of metals and it is existing in case of alloys. So please be careful about this. And remember this thing, that metals and alloys both of these above, both of these can conduct electricity, and why they can conduct electricity? Due to availability of mobile electrons. Okay, so these metals and alloys both can conduct electricity due to availability of mobile electrons. Now there is another thing, that what is the general structure of a metal? For example, this is the general structure of a metal. Positively charged nuclei are there, and they are making a regular layer like arrangement. You can see this thing. I am drawing this. Okay, so they are making a regular layer like structure. And remember this thing, that these layers can slide and slip over each other. So here I'm drawing with the red color the negatively charged electronic C. If you are not going to label the diagram, examiner will not give you any credit. Okay, please be careful about this. So what is this right now? These are the positively charged nuclei, whereas here negatively charged electronic C. And then I am now changing the board to the structure of an alloy. You can see this thing, that bigger size and then the smaller size. So it is just telling you, so what's an alloy? It is basically a mixture of two or more than two metals or metals with non-metal. So basically you may define an alloy, it is a mixture of a metal with another element, okay, that other element can be a metal or a non-metal. So we have to label this as well. So what is that? It is called as metal A. So whatsoever is the metal, okay, and then it is a metal B. So there are two types of the metals which are mixed up with each other. We have just melted the metals and then mixed up in a specific proportion. So for example, brass is an alloy, and it has a composition of copper plus zinc. Okay, so similarly, stainless steel is an alloy. Stainless steel is an alloy, and it is a combination of what? It's a combination of iron with chromium and nickel and carbon. So these are the two examples of the alloys. Brass, bronze is also one of the alloy. So remember this thing, that in all of these alloys, basically the conduction of electricity is possible due to the availability of mobile electrons. Remember this thing, that we have discussed the metal general structure in detail in the previous topic. Over there we have said this thing, that a metal is malleable. It means that it can be converted into layers, it can be converted into sheets. Aluminum foil is an example from your home. And I have told you that a metal is ductile, it can be converted into wires, layers. So the example is the copper wiring in our homes, etc. It is affording the passage of electricity through it. As copper is a transition block element, has a high melting point value. And if we are talking about an alloy, we can see this thing that due to different sizes, the layers cannot slide over each other. That's why an alloy is harder and a stronger structure as compared to a pure metal. So we can say this thing that this is a general structure about metal and an alloy, and this is what metallic bonding is. So what is metallic bonding? That positively charged nuclei are immersed in the negatively charged electronic sea. Look, there is a word for electrostatic. Electrostatic forces of attraction. Forces of attraction are there in case of metal and pure metal and alloy as well. So why it is so? Because in case of a pure metal and in case of an alloy, we should know this thing that positively charged nuclei are there and the negatively charged electronic sea, as there are two different types of the charges in case of pure metal and in case of an alloy as well. That's why the term of electrostatic force of attractions will be used for ionic bonding, and it will be used for metallic bonding as well. All right. All the best to all of you. I would like to inform you very clearly that we are done with this chapter of bonding and atomic structure in detail. And afterwards, I am going to start with some of the past papers related to bonding, inshallah. Thank you very much. Take care of yourself. See you in the next class.